Hi everyone, and can I just say how pleased I am to be here today to chat to you about some of the exciting work we are doing with FME at Atkins Realis. Today's presentation will be focused on the changes that we can make as experts in our field when dealing with our customers and clients out in the wider world, affecting that change for them to make processes easier and allow them the time to focus on what is most important to them as professionals in the fields in which they work. Of course, change for change's sake is not necessarily the best approach, and you have to weigh these things up at the start before embarking on any journey towards automation. What are the benefits, and will they be realised longer term? And once you have answers to that, it allows you to take forward potentially steps to make everyone's lives a little bit easier. With that in mind, the presentation today is going to focus specifically on how Atkins, now Atkins Realis, as part of a collaborative partnership, which was known as East-West Rail Alliance, managing over 1 million data features to BS 1192 standards and numerous automated calculation processes, delivered the first automated, digitally enabled European Protected Species Line submissions. We're going to focus on the steps that we went through, where we started and where we ended up, and there's a nice little thought piece at the end in terms of calculating how the change we ended up with could have affected savings across the entire life cycle of the project had to be implemented at the start. So as we are right before lunch, our presentation today will be nice and snappy, but with time for questions at the end. We're going to cover a little bit of the context of East-West Rail, the FME processes, outcomes and lessons learned, and like I say, questions at the end. To conclude the introduction, my name is Duncan McLeish. I'm a senior GIS consultant in the data and artificial intelligence team within Atkins Realis. I'm both FME Flow and Form certified professional, and I've been with Atkins about 2.5 years overall in the geospatial industry for about 16 years, all in through non-traditional methods of working in this sector. I originally started studying music and audio engineering and ultimately ended up, like a lot of people in the room no doubt, with a job working with spatial data and helping and assisting other people with getting their heads around the best practice in using it. With introductions out the way, let's give you a little bit of context to East-West Rail. So, that context would be that the East-West Rail Alliance, which featured then Atkins, now Atkins Realis, also had Volker Rail, Langerock and Network Rail. The project was supported by 1.1 billion, and it was to reinstate a originally mothballed railway between Bitchester and Bedford. Phase 2 covered some 50 kilometres of new railway, 3 major compounds, 9 satellite locations, and at any given time, contractors and subcontractors were involved in construction across the entire scheme. As part of this construction, they were required to produce environmental risk assessments, ERAs for short, prior to any site activities. The ERAs is part of the project's environmental risk management plan, with the purpose to establish reputable and legal practices for construction, increasing the credibility of the project and ensuring that site teams understood the environmental and ecological risks in the area that they are working, with the ERA process being handled in 3 stages. Stage 1, identifying the environmental risks at the worksite. Stage 2, completing the ERA itself. And then finally stage 3, the ERA view and approval by an Alliance environmental manager and ecologist. Once the final tool was deployed, this is where it actually sat in the overall process. So we had a centralised spatial common data environment, or SCDE, which maintained a single source of truth for all the data. Intake of data came from a variety of different sources, but was quality checked and maintained within that central database. It fed out to the WebGIS, of which the ERMP tool sat as part of that process. And from the database itself, it could feed out to a variety of different platforms, whether that be things like QGIS or ArtPro as desktop, or even into things like Autodesk as well for analysis. It could feed out into things like Power BI for visualization and for analytics, but also would be used fundamentally by the geospatial team itself to create external figures for reports. That's where we ended up, but we also have to understand where we started. And the early iterations of data collection of EMRP were handled in a variety of different methods, whether that was inherited data or use of the Atkins Assist app. Art Collector, Survey 123, or Excel spreadsheets, of course, with a variety of different tools being used and different formats being produced. This, of course, led to multiple different locations and formats of the data being stored, replication, and a lack of ease in tracking down what was the essentially up-to-date versions of those datasets. To modernise this, a two-step process was implemented, and that first step was the WebGIS, and we showed in the previous diagram. And then ultimately, we look forward to building FME form and flow automation to power the tool overall. The first iteration of the tool was the WebGIS itself, and it allowed quick access of the data to all that had access. That's stage one of the ERA. It allowed people to complete their process quicker than they had before. It was slightly less manual than what the users were originally used to, but it did ensure that everyone was using the correct version of the data itself as it was being held within that common data environment. The outcome of this first iteration, it simplified parts of the process and did allow for cost savings across the lifespan of the tool. It couldn't necessarily be classed as automated though, it was just a major improvement on what users had experienced thus far. And as soon as that first stage WebGIS was rolled out and users were comfortable in using it, we could then start to look at the processes behind it and the tools we could build in order to automate the process. To do that, we basically had to start from scratch and understand the various different steps, what the outputs were for the users themselves. We were building everything from the ground up. The sheer size of the analysis that was going to be required would require so many FME transformers that it would max out essentially any one single workbench. So we broke down the full process into what would be 8 workbenches of various different size and complexity. But building brick by brick, the outcome was always going to be that everything that was designed had to fit into FME flow. So that was the kind of overriding method to which everything was built to. If it didn't fit in flow, then we weren't interested. So what does that actually look like to the user themselves? Here's a quick video to show you the steps. So this is the WebGIS itself. The user would go and activate the tool, and once they'd done that, they would draw a freestyle polygon showing the area of interest. And up would pop a form where they would have to fill in various details. All these were controlled in such a way that no one could shortcut. And certain fields, if you ticked yes, then details were required and would have to be manually inputted in as part of the process. Once a user had selected that, they would kick off the process itself and would be assigned an ID number, and a temporary scratch layer would be drawn on the map. This would start the FME flow process in the background, and an email with a zip file would appear which contained the figure creation that they wanted, covering the area, as well as a report itself created in Excel, which would be pre-populated based on a lot of these tabs that existed within the actual form itself. So yeah, so you would start with that form. it would allow you to create the polygon. The form contained all the questions needed to automatically fill in the EPP report, and then that information triggers off the process itself. Now, we're not going to cover all 8 workbenches because we don't have enough time today, as much as I would love to. So we're going to take a look at some of the challenges that we actually came across as part of this. And the first one would be initially the job submitter itself. As you can see here, we would be potentially in a situation where more than one person could kick off this process at the same time. That could cause complications when issuing the ID number. So we created a rough and ready workaround that would essentially remove the risk of a duplicate ID number by essentially clearing them out and then recreating them at the end of the process. That would then kick into the controller server workbench, which is the next stage overall. And this one here would do a lot of the heavy lifting, identifying how enforcement of the defined area on the map would be handled. And it would start by looking at the size of the area and then what best zoom extent for the background map would be applied. So to ensure that consistency on how we actually created our figures, 7 predetermined zoom levels were actually set into the process, and then the spatial filter would select which one made sense based on the size of area selected on the map. What followed was a lot of spatial analysis, so looking at various different data sets and picking out the data sets that actually intersected within a certain tolerance of that defined area. We're going to skip over those because the next big challenge that we actually came across was how we would output our PDF. And as simple and rudimentary as that sounds, maybe not that easy overall in FME. So a complex FME PDF and raster processing workbench was created, which took a figure template and adds in data in the base maps, even adjusts the scale to the output area. To do that, there's various different sections here that we've highlighted. This one here actually uses a spatial filter to determine the zoom level. This particular area here allowed text formatting within that template. So actually controlled what was being displayed and what was being fed in text-wise, but also had to fit within certain defined boxes created in the template. And this area here is for the additional PDF formatting required for the placement of the spatial details and the correct locations. I also had to take into account that some of the datasets that might intersect with our area could be very busy datasets, for example, bat locations. So as a result, they're suppressed from the map overall and the details appear in the Excel report. Lastly, we weren't working within our own infrastructure at Atkins Realis. We're working within the East-West Rail Alliance, and there were complications in terms of how the emailer would handle emails being submitted directly from FME. Sometimes this would time out or fall over, and as a result we had to create a loop process which would essentially, over the period of about 60ish minutes, try again if it hadn't succeeded in submitting that email that contained the zip file and the overall figure and Excel. But the good news is that from what we had before with the web map, actually from hitting submit to the user nominally getting an email with data, usually took about 5 minutes overall for the process to run. And whilst it looks really busy in FME form, Flow, if you've used it before, is relatively straightforward once you get your head around it, and it's connecting up those processes in one linear succession, and straightforward enough to set up for us, but hugely powerful tool that we instantly found we could be doing more and more with the longer we worked with it. And at the end of the process, the user got a zip file via email. It would contain an output map and a pre-populated Excel worksheet, and the worksheet itself is driven from the inputs that the user had actually selected on the map, and those FME processes pre-populated and highlighted answers to questions specifically on the permit for consideration. So it would drive those answers directly into Excel, and we'd already set up conditions that would highlight the particular areas. So what did we have as outcomes and lessons learned on this project? I think the big one is that we realised that We had incrementally upskilled our clients and users and processes over 2 stages to allow an acclimation to those new tools and procedures, rather than just trying to move into the future on everything. We took those steps, first getting users used to using web mapping and web tools, and then the automations that power them in the background. Everything we created always had FME flow in mind. It always had that end result of automation. And lastly, we retained the same outputs that existed before. We didn't try and change mechanisms which made sense to the users. Rather, we made sure that our tools interacted and populated them in a correct way. So the users, their experience at the end, the report looked the same, but the processes in the background took all the heavy lifting away. And yeah, a kind of final thought piece exercise here is on life cycle and how much could have been saved. Looking at estimates, we worked out that there was a cost saving of about 6 or 7 hours per report. And once we worked out how much the cost per hour was per person, we could anticipate that actually across the 4-year life cycle of the project, some £98,000 could have been saved had our automation been implemented at the start. This has been seen as a wide success, as you can imagine, and on future projects in rail, we're already looking at how we can adapt the existing tool we have to then implement them from the start, so our clients specifically can gain the benefit from the very beginning. So yeah, that's how we did what we did, and thank you very much for your attention at this stage. Does anyone have any questions?